Hey everyone, this is my Physics 2211 Lab 1 report. So here is a brief overview of what I'll be covering in this video. First, I'll start off with an introduction, then the fundamental principles, procedures and experiment, analysis from the tracker, sources of error, and I'll conclude with the discussion questions. So starting off with the introduction, the main purpose of this lab was to observe an object moving at a constant speed in a straight line, using tracker to analyze the object's position and comparing the observed position with a computational model based on the momentum principle. In this experiment, the object that I used was an expo marker, and I also utilized tracker and glow script. A preview of my overall lab report is that my observed model deviated from the computational model. Now we'll get started with the fundamental principles. First, we have Newton's first law, which states that an object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity unless acted upon by an external force. A computational model based on the momentum principle was used because it directly relates net force to the rate of change of momentum, which lets us predict the object's, in my case the expo marker's, motion from observed positions and times. The momentum principle states that the net external force acting on a system causes a change in its momentum over time such that the net force is equal to delta P over delta T. So here is an important equation, the velocity update formula. We derived this formula by using the net force is equal to delta P over delta T, and after doing rearranging and substitution of the terms, we ended with the final velocity is equal to the initial velocity plus the net force over m times delta T. Continuing on, you can see that if the net force is equal to 0, the second term in the velocity update formula will cancel. Then we will have the final velocity is equal to the initial velocity. So for this lab, the first thing I did was I recorded a video of me rolling an expo marker across a table at a constant speed in a straight line, using a ruler as a calibration stick. I then uploaded the video to Tracker to track the observed position of the expo marker in each frame. I then created a computational model using the starter code on GlowScript to get the predicted position of the expo marker. I collected data from both Tracker and GlowScript to create spreadsheets, and I compared and contrasted both the observed and predicted data points to create a graph on Excel. So here is the video that I uploaded to Tracker. As you can see, the system is the expo marker, and the surroundings include the table surface, the earth, gravity, etc. So now we have the analysis from Tracker. The initial position of the expo marker, which is circled in red, is 0.05409 meters, and the total time it took the expo marker to roll across the table was 1.933 seconds. So continuing on from the previous slide, I calculated the average velocity by doing delta R over delta T, which is equal to the final position minus the initial position over delta T. I then got 0.2348 meters per second as my average velocity. So now we have the computational model. Highlighted in orange is the code that I edited. The mass of the expo marker, in this case ball.m, is 0.0145. The initial conditions were set from tracker data points from the previous slide, so ball.position and ball.velocity. Delta t was set to 0.033, which is the size of each time step on tracker. The ending time of the loop was changed to 1.933, which is the total time it took the expo marker to roll across the table. The net force is 0, and ball.velocity and ball.position were updated to be the velocity update formula and the position update formula. Here are screenshots of output after running the program. Pictured here is the observed and predicted position versus time graph. The blue line represents the observed model, while the orange line represents the predicted computational model. You can see that the blue line slightly deviates from the orange line. So now we have sources of error. Some possible sources of error include tracking the center of mass, for example, misidentifying the exact point on the expo marker to track in each frame. Another possible source would be timing issues, for example, starting or stopping the video too early or too late, and also video lag on tracker, which causes delays. And even though we assumed constant velocity, there could be external forces outside of our control. For example, the table that we used had an uneven surface. Concluding with the discussion questions, what if? So the answer to this question is that the difference would be that the slope would be negative, but the magnitude of the slope essentially stays the same. So what does it mean? The answer to this question is that it's not possible to say, since we can't really determine exactly which forces or how many forces are acting on the object. In this experiment, there are other external forces at play. Thanks for watching my Lab 1 report video.